Hello everyone. Today we're going to be looking at Unit 5, page 7, which is our combining like terms page number 1. Our objective for today is to simplify the sums and differences of like terms. So we're going to learn what like terms are, and then we're also going to be looking at what happens when we add two like terms together. That's our sum. And what happens when we subtract two like terms to get their difference. Okay. Before we do that, let's take a minute to do the DIN here. Review should be very similar to the practice questions from Tuesday's class. And then the preview, I just want you to think about it for a second, maybe write down some ideas. But we're not going to quite go over that just yet, because that's actually what we're going to be learning in this lesson. So pause your video here, and then we can go through the review together. All right, hopefully you pause your video for me. We are going to go through the review question, and then I'll kind of read through the preview, but we will leave that for now. With this first part, it says use the distributive property to simplify the following expression. Okay, if you remember from Tuesday's class, and maybe even from earlier than that, we had two different methods that we could use. One was the area model method, where you would set up both of your expressions here, -4 on one side and the 5x plus 2. And then if we were trying to find the area of this rectangle, we'd have to multiply both by each other. But to make it even simpler, we want to break those down into two squares here and multiply the parts separately. Okay, there's my little multiplication symbol. -4 times 5x gets me a -20. And then the x stays the same. We don't quite know what that x is going to be yet. -4 times that +2 gets me a -8. And then if I was going to rewrite this, I would write it as -20x plus that -8. Okay, we can't forget about our symbol right in the middle there. If I wanted to use the algebraic method, or the everybody gets cake method, I would rewrite that expression here. -4 times my 5x plus 2. And then the 5x gets some cake, it gets multiplied by that -4. And the 2 gets some cake, it gets multiplied by that -4 as well. So again, -4 times 5 is -20. We keep that x the same. That addition symbol goes down automatically, and then that -4 times that +2 gives us the -8. Okay, we can see that we got the same answer both times. So then the preview question just says our expression from the review question was left as a binomial, right? It has two terms, the -20x and then the -8. Which is actually its simplest form for now, because we don't know what that x is. But what if we were left with a trinomial instead? What if we had an expression with 3 terms? Think about how we might be able to change it to a simplest form, and just write some ideas here. We're actually going to be learning how to change it to a simplest form in today's lesson. That's what our notes are going to be about. So I'm not going to give us the answer here quite yet. All right. If we go down and we look at our exercise 1, it says for each of the following expressions, rewrite the sum as a product. Okay. We don't actually have to find the solution. So what that means is we're not going to add the 3 plus 3 plus 3 5 times, which would give us 15. We're actually going to try and rewrite this as a product, or kind of a simplified expression. Instead of adding 3 5 times, we could have taken that 3 and just multiplied by 5. Right? Same thing with this 7 here. Instead of adding 7 3 times, we can take that 7 and multiply by 3. And these would still give us the same answer. Okay, 3 plus 3 plus 3 plus 3 plus 3 is 15, but so is 3 times 5. 7 plus 7 plus 7 is 21, but so is 7 times 3. Okay, this second number is what I'm just getting from counting how many times we were adding. So now we're going to do the same thing with some variables. If I have x and I'm adding it together 5 times, that's going to be the same as taking that x and multiplying it by a 5, just like I did with the 3. If I have y 3 times, it's going to be the same thing as taking that y and multiplying it by 3, just like I did with the 7. Okay? Even though we don't know what these variables are yet, we can kind of use the same methods that we would to simplify these super long sums. The next exercise that we're going to do is kind of the opposite. Now they're giving you one term and they'd like you to break it down as a sum. Okay, so right now we can think of this 4x as a 4 times x, right? We always have that multiplication in the middle. But if they want this as a sum, we're going to have to take that x and add it 4 times. Okay, x plus x plus x plus x. Okay. I think you guys are kind of getting the hang of this now. So go ahead and pause the video here. Try to get the last 3 for me. Take that variable and turn it into a sum using the number or the coefficient that they're giving you. If I take this x and I want to turn it into a sum, I would add it 3 times. All right. Hopefully you also tried B and D here. I know I've kind of been going out of order, but that's okay. We want to take this variable now. We have a y. And instead of 5 times y, we're going to change it to a sum by adding y 5 times. There's 4 and 5. Okay. For D, it's going to kind of be the same thing, except we want to be careful with that negative. Okay, we're going to have a C, but now it's actually going to be a negative C. Okay, and when we add negative C plus a negative C, that gets us -1 plus -1, which is -2c, which is the same as our product there, -2c. Okay. So that one's just slightly different. Be a little bit careful with those negative signs. Using parts A and C now, okay, so the 2 expressions that we created here, they want us to take this bigger sum and create an extended sum. So this 4x, we've kind of already extended that. We got it up here, x plus x plus x plus x. So I'm going to copy that first. And I did that in green. But now when I extend my 3x using part C, I'm actually going to change the color for now. And I'm going to put those in red. Okay, so far I've just copied part A and part C. They actually want us to add these together now. We have this addition symbol here. I'm going to put it in blue. And let's kind of think about what happens. If I have 4 x's here and 3 x's on this side, but I'm adding them all together, it's kind of like I just have 7 x's, right? They don't really have to be split into these different colors. So I actually want to put them together, okay? And 7 x's added all together is the same as x times 7. Or if I was writing that as one term, 7x would be even simpler. Okay. And we're going to try the same thing with f. They want us to rewrite our 4x and our 3x again, so still using part A and C. This time we're going to be subtracting, okay? And even though they say that we're subtracting here, they still want us to have it as an extended sum. So we're going to kind of think back to leave, change, change, and create that expression, okay? So let's do the same thing. I'm going to have my 4x. I'm going to keep it in green. This is, again, still from part A. We already split that up. Then I'm going to have my blue subtraction symbol right in the middle here. And I'm going to go to red for my 3x. It's part C that we've already done as well. Okay. But they still want it as that sum, like I said. So we have to use leave, change, change to actually create that. If I am going to use leave, change, change, okay, I leave that first term alone. I have to change my operation right in the middle. So I'm going to do that in black here. I'm going to change it to addition. And then I'm also changing the third term, right? But here's where you want to be careful. If I was just doing this on the original expression, I would change that subtraction to addition, and then I would only need one negative symbol on the 3x. But like I said for part D, when we're trying to extend it, we need those negatives on all of these. Negative x plus negative x plus negative x. Okay, so we left the first group kind of alone, changed our operation, and then changed that second group or second term by putting on those negatives. And now when I go to add these all together or kind of simplify, these positive x's will reduce to 0 when added to these negative x's, right? So I can actually go ahead and cross some of these out. If I have a positive x, that's going to reduce to 0 when I add this negative x. If I have another positive, that'll reduce to 0 when I add this negative. And if I have one more positive, that will reduce to 0 when I add this last negative. Okay, so I'm really only left with that 1x, which is actually our answer. X times 1. Or as one single term, we could just put an x there and keep that one kind of invisible. Question G here says, what do we notice about the coefficients in the original expressions compared to the coefficients in our simplified answers? And so that's actually, that's asking about these coefficients. If we started with 4 and 3, we're adding those together, what do we notice that happens in our answer? And if we started here for part F with 4 and 3 again, but this time we were technically subtracting, notice what happened to that coefficient for this answer. What's kind of a pattern that we're seeing? Take a second to think about that for me. Okay, perfect. So hopefully you paused the video there and you thought about that for a minute. We noticed that our coefficients from the original are actually being either added or subtracted to get the coefficient of our answer, okay? So 4x plus 3x automatically gave us a 7x. The 4 plus 3 were added, and the x just stayed the same. 4x minus a 3x, or plus a negative, gave us the 1 as a coefficient, and then the x's just stayed the same. Okay, so in part G here, you guys could write that down, just kind of your observations that you thought about. And for part H, I'm going to kind of give you the rule. I'm going to type that in for us here. One rule that we can use to generalize the simplification of any sum or difference. Okay, as you guys can see, even when we're subtracting or we have that negative, it'd still be written as a sum, or we can call it a difference. Either one works. And the rule is to just take those coefficients and do the addition or subtraction, and then keep your variable the same. Okay. So when I am adding or subtracting terms, I can add or subtract. Oops. Just the coefficients. Oh, definitely did not spell that right. And then keep my variable the same. I'm just going to change that color here so we can tell that it was notes that I added in. Let's just go with red here. So take a second, copy that down. That's our rule that we can use. No matter what terms I'm adding or subtracting, I can add or subtract using leave, change, just the coefficients, and then we keep the variable the same. Okay. Next part that we're going to look at is part I. So still kind of looking at the same exercise here. We're going to be using part D, or sorry, B and D now of these exercise 2 questions. Okay, B and D, 5y and a negative 2c. Do we think our rule would work for 5y and that negative 2c? Take just a second, write down yes or no, and then let's kind of do the work together. All right, let's check. If I take that part B from exercise 2 that we did above, 5y would look like this. Y plus y plus y plus y, and one more. And then if I take that part C that we did, even though I am using my leave, change to turn this to addition, I would still have that negative 2c there. Okay, so I'm adding, but then my c's that I put on should be negative. So what do we notice about these? If I have 5 y's and 2 negative c's, can I put those together? It's kind of like if I had 5 apples and then I said, take away 2 oranges. Would that make sense? Those are 2 separate, there'd be numbers in this case because that's what our variables stand for. If we think about them kind of like objects, do we think we can actually combine those? No, right? So we have this new vocab term that's called like terms, and it actually tells us when we can or cannot use this rule. Okay, in my rule, I just use the word terms in general, but we're actually going to add in the word like. Okay, we actually have to have like terms before we can use this rule. I'm going to show you what that means in just a second. Okay. Like terms are two or more. Okay, so you have to have at least two if you want to put them together. Terms with the same variable. Okay, so in part H, the reason why we could combine those is because they were both x's, right? 4x and 3x, 4x and 3x. Again, both had x's. But now with this part here, y and c are two different variables, kind of like two different objects, apples and oranges, that can't really be combined. Okay. And so now we're going to do just quick two more exercises before I let you guys go to do your practice on your own. Exercise 3 says pair each of the terms on the left side, so these four here, to any of the like terms that we can find from the right side. And we're going to be adding them together. So I'm going to show you what that means with our first question here. Let's see, where's my draw tool? 6x can be added to the 7x, right? Because it has a like term. And then if I check all of these other ones, nope, they're not the same variable. I can only add that 7x. And then you guys can tell me what that answer would be if I simplify it. And if we remember, we take the two coefficients and add them, and then we keep our variable the same. If I tried that with 3y, first I need to find what I'm going to be added. Let's look at all of the terms here with a variable y. There's 2. So I want to add 12y. And then I also want to add a negative 11y. Okay, even though that negative is there, we're still adding. So I want to take all three of those numbers, and you may need a calculator for this as well. So go ahead and use your desmos.com/scientific link if you need to. 3 plus that 12 is going to give me a 15. But then when I add a negative 11, I should just be left with a positive 4. Okay, so I'm taking just those coefficients and doing the addition. And then I'm keeping my variable the same. That's what my rule told me to do. Take a second, pause the video here, and try 3 and 4. Can you find those like terms and add them together for me? All right, hopefully you paused that video. I'm going to go ahead and try to find the like terms to 7s. It looks like we have 2 again. We have a negative 2s and we have a negative 13s. So again, even though they're negative, I'm going to add those. Seven plus a negative 2 gets me a positive 5. But then that positive 5 plus a negative 13 is going to leave me with a negative 8. And I keep my variable the same. Same thing with our last one, negative 9t. I'm going to look for all of my terms that have that t variable, and I can add those together. It's getting a little bit harder. Now we have 4 terms, kind of a bigger polynomial. Plus 5t, plus negative 3t, and it doesn't really matter what order you do these in. And plus an 18t. When I use my calculator to add those all together, I should get a D. Believe it should be a positive 11t. And exercise 4 is just one last quick multiple choice. If we tried to simplify this polynomial here, we have 4 terms. Which choice do you think it would be? If I tried to simplify those 4 terms, which choice would it be? Think carefully about which terms are actually alike. Okay, let's go through this one together. I'm actually going to do a quick trick here that I like to use. Anytime you have an expression that has some variables, some constants without variables, or maybe there's mixed variables, like I could have an x and a y, I like to use my different colors or maybe a highlighter or a marker, or even just a pencil. You could create different shapes with a pencil, right? And I want to box in the ones that are like terms. This 3x is like terms with this 8x because they both have x's. But the 7 and the -2 here are not like terms with those x's. They don't have the same variable. They're only like terms with each other. Okay. And then what we can do, we can take that 3x plus 8x, and that's going to give us 11x. But then we want to take that 7 plus that -2, and that's actually going to leave us with a positive 5. So this should be our answer choice here. Okay. I was only combining my red boxes because those are like terms. And then I was only combining my green underlines here because those are like terms. But in our final answer, we have to leave those as a binomial. Okay, it can't be simplified even more. All right, guys, hopefully all of our exercises kind of made sense as we went through the whole process. Now you have a few practice questions that do get a little bit harder, so feel free to use your calculator and use those methods of circling the ones that can actually be combined, and then maybe underlining or boxing in the other terms that maybe can't be combined. Okay. And then when you're done with that practice, complete your quick exit ticket. Make sure you fill out our self-reflection. And then our last activity for the day is to pick one choice from the same choice board that we looked at earlier this week. All right, guys, thank you.